All right, welcome back. This is another video on solving systems of equations by substitution. In the past, we've had some nice convenient equations where one of the equations was x equals some stuff and x was all alone, or y equals some stuff and y was all alone. And that made it really convenient because we could just take whatever was equal to x and substitute it for x in our other equation. Now, life isn't often that convenient, so here's an example of a system of equations that would be more likely to happen in a context. So both of them have x's and y's on the same side of the equation. So in order to make a substitution, we have to solve one of these equations for one of the variables so that we can make our substitution. Now, it doesn't matter which one you do that with. If you take the steps correctly, you will get the correct answer. However, you can sometimes save yourself some hassle by considering what will happen when you solve for the variable ahead of time. So, in order to get x all by itself, you will at some point have to divide by that -7. Well, if you divide 6 by 7, you get a fraction that doesn't reduce. It doesn't simplify to an integer. 4 divided by 7 won't give you an integer. So what happens if we do it with the y? If we divide by 6, well, 7 divided by 6 is a fraction. 4 divided by 6 will be a fraction. They won't give us integers. Okay, let's think about what happens with the other equation. If we divide all of these terms by 4, so that x is a single x and not 4 x's, that will be 12 divided by 4 is 3. 32 divided by 4 is 8. This is good. This means that if we solve this equation for x, we'll have no fractions, which will make the algebra that we do easier. Okay, so let's go with that. We'll solve for x. We want to get 12y to the right side of the equation, so we'll undo addition by subtracting. We want to get x to be a single x, so we undo multiplying by 4 by dividing by 4. So that'll give us x equals -12 divided by 4 is -3. 32 divided by 4 is 8. Now, wherever I see x in this other equation, I can replace it. I can substitute -3y plus 8 for that x because they're equal. All right, let's do that. -7 times, instead of x, this expression, -3y plus 8. And then we write the rest of this, -6y equals 4. Excellent. Now, we've got a single equation with a single variable, so we can solve for that variable. Start by distributing -7. -7 times -3y is positive 21y. -7 times 8 is -56. And then we write the rest of this, -6y equals 4. Now, combine like terms. 21y minus 6y is 15y. If we add 56 to both sides of the equation, that cancels this -56. 56 plus 4 is 60. If we undo multiplying by 15, we will get y alone. And 60 divided by 15 is 4. So if we did everything right, we now have the y-coordinate of our solution, or our intersection of these two lines. So we'll take y equals 4 and we'll substitute 4 wherever we see a y. Let's do that, not in the equation we came up with by doing some algebra, because if we made a mistake, it won't matter whether that is okay in this or gives us a certain x value, because then it would be the wrong x value. So, substitute what you found y to be into one of the original equations. We'll put it in to this one. So we get 4x plus 12 times y, the y is 4, so we substitute 4 for the y, and that equals 32. And then we can solve this equation for x. So we get 4x plus 48 equals 32. Subtract 48, and that gives you negative 16 equals 4x. Divide by 4, and that gives you x equals negative 4. So our solution should be negative 4, 4. We've shown that that's the case for this equation, so we also need to check out, is it the truth for this equation? So let's substitute. We'll get negative 7 times the x value is negative 4, minus 6 times the y value, which is 4, and that's supposed to equal 4, so let's see if it does. Negative 7 times negative 4 is positive 28, minus 6 times 4 is 24, equals 4. 28 minus 24 does equal 4, so we have checked out both of those and confirmed that this is the correct answer, the one solution to this system of equations. This point, negative 4, 4, is the intersection of those two lines. And we're done.